as I mentioned before on the chat, we have tons of time for questions today. So really, today is a great day for questions, especially because I know it's been a lot. So again, this is the background for today. If you like anime at all, I'm sure you've seen this one. And if not, I would highly suggest you do. Not a new one, fairly old. It's a movie, but it's really good in every sense of the word. And it's still very much related to the world today. All right, so let's get started. And here's a question before, just to get warmed up. How do you feel about aggregate functions today? And which one's your favorite one, if any? Give me no, it's not Pokemon. So yeah, so Pokemon, interesting, yeah. I don't know if I'd call Pokemon old, but that's just me. Yes, this is definitely Studio Ghibli. And in particular, I really, if I ever see Totoro in a Pokemon movie, I'm just going to start boycotting everything Pokemon. He doesn't deserve to be inside a Pokeball. All right, so how do you feel about aggregate functions today? Need to practice, yes. Excited. Okay, still a lot to learn, yes. So aggregate functions and the whole concept with SQL, it's sometimes it's a matter of the grasp. So this is important to try and build the intuition. If you get the intuition, then the practice becomes much simpler, and it's all a matter of figuring out how the code works. Because of that, so since last time you see the table example seemed to help, today I have a little bit of an example also using tables, because it helps us sort of understand the logic and the intuition behind subqueries. So I'll talk about subqueries, then we'll go back to the couple of exercises that we didn't do from last session, and then we'll get on to the rest of today's session. So imagine we have this table. I'm using very small tables because it helps us understand it better, but we tend to handle or work with tables that are huge. That's why all of these makes much more sense once we know that we're using tables that have millions of rows and maybe 20, 30, 40, 50 columns. So they are really big, so we want to make them smaller and smaller and smaller to make them more handleable or easier to handle. So imagine we have this one. All it has is 15 rows of customers. We have their name, we have their age, we have their location, just country-wise, and we have two Boolean variables, whether they drink coffee or not, and whether they drink tea or not. So if I run a query on this table that looks like this, select name from customer where age is bigger than 40, I should get these 4 names. So feel free to check out if I did correctly. So I should get Mateo, who's over here because he's 45. I should get Luca because he's 52. I should get Emma because she's 61. Oh, what is a Boolean exactly? Oh, great. So Boolean is a very particular term in computing that means either a 1 or a 0. So Boolean just means it's either true or false. True is a 1, false is a 0. That's it. That's what Boolean means. And we use it for a lot of things because computers are binary. So computers, in the most common sense, they just manage in 1s and 0s. So a Boolean is just 1 byte or 1 bit actually of information. So just think about it. A Boolean is either a 1 or a 0. That's it. That's the only 2 options. So we use them for yes and no questions a lot. So for example, this just says, does the person drink coffee? 1 for yes, 0 for no, or better yet, 1 for true and 0 for false. That's it. All right, so let's, Oliver, we already have Oliver, no, not Olivia, Oliver, yes, he's 58. So yes, and then Noah because it's 41, and Elias because he's 67. Great, so we have this smaller table. Now, remember, when I run this code, this is what I get back, okay? I don't get back anything else from the table because I'm just asking for the name. Now, the importance here is that, so again, I'm just asking for the name. So this is all I get. All I get is the stuff from the name column. I get nothing else. But this is a new table. And this new table, I can sort of use it somewhere else. And that's sort of the logic of subqueries. So imagine that if I already had this, and imagine this might be a lot bigger, maybe I don't actually know what the whole content is. Maybe I don't know some other things. I just want to make this quick in one query without having to investigate further. Then I can use this query as a subquery in another one. So what would happen if I already have this table, I know what this table is, and now I run this query. I select everything from customer where name is in, and I do a subquery when the name is in this other query. So remember, I'm querying this table over here. This is the customer table, and this is my subquery table. So what should I get back? What would be the result of this other query? So I don't get both tables because I'm using this subquery in the where statement. So that is correct. That's a very good description. All the information related to the names from the first query. That's literally what I'm asking about. So I'm saying if the name is in this table, I want their information from this table. So it's gonna do this. It's gonna take Mateo. It's gonna look for Mateo Lopez. It's gonna say, is Mateo Lopez, because Mateo Lopez is in here. This is my filter. I'm gonna go into the big table, look for Mateo Lopez, and get all of his information. So copy here. Boom, I have all the information from Mateo. Then it's going to look for Luca and say, since Luca is here, it's going to look for Luca Bianchi in here and bring all of the information. Then it's going to look for, oops, why did it give me a number 2? Luca, where's Luca? Luca is this one. I know why, but it's okay. That should be a 4. Then it should look for Emma. Where's Emma? Where's Emma? Emma is here. Take Emma, and I'm just gonna paste special values so that I actually get the 7. Then Oliver, then Noah, then Murphy. So I'm gonna go Oliver. He's a 10 just in case. This one's a 7. Noah, where's Noah? Noah is over here. And finally, Elias, who's over here. Just in case, Noah is 12 and Elias is 15. All right. So that's it. That's how the subquery works in this case. In this case, I'm using it as a filter. Also, yes, Kalim, in this case, there's another way. I can just say, select all from customers where age is bigger than 40, and I would get the same thing. Now, again, because I'm using a small table just for explanation basis, it seems like using a subquery is probably not the best way to go. And you would probably be right in this particular case. It would be much easier to just use age in the where table. Nonetheless, and here's the big issue, these tables can become much more complex. So again, imagine that you had a table that had 40 different columns and millions of rows, and every time you want to run, and there's a point where you sort of run the risk of not exactly knowing a few things, or not exactly knowing how to, or the table is just too big, so you need to make it smaller and filter it once so you can understand it better, and then filter it even further. And that's the whole concept of subqueries. Elias is 14, you're right, Elias is 14, sorry. The thing is how I build this table instead of 1, 2, I just use the formula and it's copying it. So that's the only issue. But what I want to say is the important thing is that you understand it's not whether it's the best way to use subqueries or not, it's how they work. Because some cases, yes, we're going to need to use subqueries, and I'll give you a couple of examples on that on today's lesson. All right. Questions on subqueries, so we can go back to the exercises from last week, from last Tuesday. Oh yeah, and by the way, today's data set is the same data set that we used on Tuesday. we're not switching data sets. All right, so coming back, here's a big question. For the last two exercises from Tuesday, we have two options. Either I give you time to solve them and then come back and solve them with you, or do you want me to walk you through them slowly and work on them together? Which one do you prefer? All right, so let's walk through them. Wonderful. Okay, so this, I just did like a little bit of a filter, and these code right here gives me our top 5 agents. So just to walk you through what I did here, and let me actually share the code with you in just a second. Boom, boom. Share the code. Here you go. All right, so what I'm doing here is I'm selecting two things. I just want the agent name as agent. I'm just calling it agent because name doesn't make sense, just agent. And I want agent, their ID. That's all I want. So in this case, but I actually want to do a couple of filters. And those filters, I'm going to have to join tables to do them, because I don't want only the name of the agent. I want some particular names. So in this case, I'm getting everything from call first, and I'm joining agent on agent ID equals call ID, and then I'm joining customer on customer ID equals call customer ID. Okay, so again, I'm joining all tables, and you'll see in a bit why. So I'm using the where statement. I'm saying call picked up equals 1. So this is the reason I needed the call table, because I wanted to see that the calls were picked up, just like we did on Tuesday, and that the customer age was more than 19, so that they were 18 or older. So again, this is why I needed the customer table. So again, all of this information comes from the agent table, but I needed to do the filters from the call and the customer table. So again, these are the agents, the top 5 agents that are ordered by this particular thing, which is the average of call products sold. So if you remember this, when we actually ran this code before, and we actually saw who were the best agents according to the percentage of their product sold, how much they sell. But in this case, all I wanted was the name of my top 5 agents. So I actually filter it. I filter it by these two. I order it by average product sold, and I limit it by 5. Okay. So here, all I'm doing is giving me the list of my top 5 agents. That is it. All right. So here's a question. And this is what we're going to do. I actually want the names and ID numbers of the bottom 6 employees. So what would I need to change here? Any ideas? I can actually do it with practically the same code, but I need to do some changes. What would you change? So that's a great one. So the first thing is that this list, if I remove this limit 5, this is going to happen. So now I get the whole list. So these are my top 5, the first 5, and then I got my bottom 6 are over here. But I really want my bottom 6 to be ordered in which order they're the worst. So I want to see who is actually the worst. So if I actually keep this as it is, I just get the list of all 11. So somebody was very clear. So instead of ascending, I want them descending. So once I do them descending, this is what happens. So now I get my worst 6 agents first, and then the top 5. So the only thing that I should do in this one is to limit it to 6, because I want the top 6. Or sorry, the bottom 6. Okay, there's a reason, and it's going to come clear in a bit, why this is important, because this is going to help me filter things much, much quicker. And you'll see why. So what I want you to do is make sure that you keep this information. Okay. So this information over here, these ID numbers are the ID numbers of my worst 6 agents. And again, it's going to be important in just a bit. So keep those up, and also go back to the other one with the ascending list and limit 5. Keep your list of your top 5 agent IDs, but just the IDs, and you'll see why in a bit. I see a couple of people typing. So that's it. That's all we needed to do to figure out this one. So just change ascending to descending and limit to 6. And we have our bottom 6 agents. So now we're going to write 2 different queries. In particular, I want to figure out the most important things about, both my top and my bottom. And in particular, something that I've already found that's interesting on the data. So I want to see the agent's name, the total number of calls that they made. I want to see their product sales conversion percentage, which all those things we've done before. But in this case, I want to filter each of the queries to include only the calls with customers who are 35 or older, because it seems that these purchase a little bit more, and that have engineer in their job description. Okay, so let's actually start doing this slowly. So again, it's 2 queries. We want one for top 5 agents, and we want one for bottom 6 agents. So let's start with our top 6 agents. Okay, so let's start with our select part to see what we need. So let's select, and what do we want? So I want you to go over here and remind me of what we want. So there's 3 things. What should go first? So agent's name, that's the name. So I'm going to work at the same time and do a little bit of a shortcut, which we're going to look at today a little bit more deeper. So I'm going to say A, and I want name. And let me just recheck it's agent.name. So I'm just going to call it A, and you'll see this is an alias I'm giving the agent table, and it's going to become important in a bit. I just can't do anything with it right now. All right, so I have the name. What else do I need? Nope, I actually don't need the ID. So should show agent's name, total number of calls they made. All right, how do I get total number of calls? So think about the fact that I'm definitely going to have to join all of the tables. So that's great. So that's good. So that's a good question. Should it be count or should it be sum? I want to know the total number of calls. How many calls they made, no matter what happened during the call. So if I do sum, what am I summing? So let's take a look with just a second. So here we have our call ID. So how do I know, what can I sum in here to know how many calls somebody made? So no, I'm not counting sales, I'm counting calls, how many calls they made. So this one's important. This is where it's important to figure out which one's better, whether it's count or sum. In this case, it's count. We definitely want count. Why? Because we want to count how many calls there were. So I'm actually going to use count all, and I'm going to call it num calls, for number of calls. All right. So very important. No, I'm not counting picked up because I'm actually asking the total number of calls they made, not how many got picked up. We want to see the total number of calls they made. Okay, so that's important. So again, this one has to be count. Count duration, well, yeah, but the thing is that if I only ask for one particular column, when at the end of the day, I'm going to have one row for every call, I can just count them, because remember, we're still going to group them by and we're still going to filter them. And now we need the product sales conversion percentage. So here again, you only want to count a particular row if you think you're going to find null values, because remember, null values get ignored. But if you actually want to count everything, even if there's one particular part with null values, you want to use count all. Very, very important. So we have to make sure that that's happening, because remember, if we're grouping by, the group by is still going to group it by the particular agent, whether I use the ID or anything. And what's the last one? We want average product sold. So how do we get that one? The product sales the conversion percentage. Does anybody remember what we use in this case? Yeah, we use average what? Here's the schema. Yes, 100 times average of what? Yes, average product sold. So here I need average. I'm going to do 100 times average product sold. And very important, this one comes from the calls. And I'm going to call my call table, I'm going to call it C. And this is going to be as conversion PCT, conversion percentage. Great. So now that that's done, that's all the only three things that I need. Now I need to figure out my joins. So I'm going to start with the call table. By the way, do I need to make any left joins, any full outer joins, or are they all inner joins? So yeah, I think they're all inner joins. So I'm just going to use from call, and then not call ID, just call. And I'm going to join. In this case, let's start with agent. It doesn't really matter in this case. Oh, very important. So there's something about, so I did this here, see, the C.product sold and this A.name. So that means that I'm aliasing the tables. So the place where we actually give the tables an alias is here in the from statement. So I'm going to do call C. That's it. So call space C. This is telling SQL that everywhere else, except for the from statement, I'm calling this table C. And that's going to make my life a little bit easier. And you'll see why in just a second. So now I'm going to join. And I'm going to join agent. My agent table, and I called it A. So I'm going to call it A. And here's where it starts becoming a lot simpler. We're using aliases. On C.agent ID equals A.agent ID. Okay, so now I didn't have to write call or agent, just A. And everywhere else, except from right here, I'm just going to refer to call as C, and I'm going to refer to agent as A. Again, just a little bit of a shortcut. Now, I'm missing one table. So how should I call this table and alias it at the same time? I'm missing my customers table. So what do I do now? Yes, join customer. Customer, and how do I alias it? CS, CT. So that's the thing. I can't do C because call is already C. So this one has to be something else. So yeah, I'll pick CT. That's good enough. Yes, aliases can be more than one letter. We just use just one letter because it's shorter. But yeah, you can use more than one letter. Of course, if you alias it to something too long, then it sort of misses the point. of trying to make it a lot simpler. So in this case, is CT dot customer ID equals C dot customer ID. All right. Somebody asked, I missed something. Can we give agent ID alias as well? Yes, we can. We could say, so a name as agent. I'm just going to call it agent. All right. So we're done here. Now comes the fun part. Now we need to do some where statements. So again, remember, we're writing two queries. The first query, so refer to table name on from since. So here on the from is where you give it the alias. Everywhere else, you're going to use the alias for it. But because SQL has a strange way of actually executing, and it's going to, the select statement actually runs third or fourth. A from statement runs first. It's first going to go here and check what they need to join and what they need to do with the tables, and then run other things. So C agent ID means, okay, so C agent ID, that's a good question. Over here, C agent ID means it's the same as doing this, by the way. Call agent ID. Now I can call it C agent ID because I aliased call as C. That's it. And CT is just the customer table from now on. If you see a little letter or a couple of letters after the name of the table, that's what it means. All right. So in my where statement, what is it that I need to do? So first of all, I need to filter this by my top 5 agents. So how do I do that? Because remember, I needed to write a query for my top 5 agents. That's it. So who saved the agent IDs, by the way? Yep, we're going to add the age is bigger than 35. Yes. The limit 5, that's not going to work. I actually need to filter it. Yep, CH, we're going to do that. But first I want to filter my agents, my top 5 agents. Yep, so how do I get my top 5? So this is the way we're going to do it. I'm going to do C dot, so my C dot agent ID. So I'm using the call table, agent ID, and I'm using an in statement. And remember, I told you to save the numbers, and I'm actually going to just pick the numbers, which I actually saved. So that's it. These are my top 5 agents, by the way. Agent 1, Agent 3, Agent 6, Agent 9, and Agent 10. So as long as they're in here, I get my top 5. That's it. So that's wonderful. Okay, so that's my first filter. My second filter that they're asking, only include calls with customers who are 35 or older. So somebody already gave that to me, and that's great. So in this case, it's not C.age, it's going to be CT.age. Because remember, my customer table is called CT now. And CT age has to be bigger or equal to 35. So that's my second filter. And my third filter, so another end. Yes, we can write the order of the where statements if is not relevant. So the last one is whose job contains the word engineer. So how do I do that? So let's look at this here. Do we have a job? And yes, we have one. See this one? It's called occupation. This one over here. So how do I write filter? All right, interesting. So that's an option. Let's see if that works. CT dot occupation. Somebody's saying that I should do equal to engineer. So should I use equal in this case? So it says 35 or older and whose job contains the word engineer. So true, we should do like. So it's just like engineer, or am I missing something here? Let's see if we remember how we use our wildcards. All right, so where does the percentage go? Here or here? Ah, great one, Marta. Yes, it goes at the beginning and at the end, because I don't know if engineer is at the beginning of the word or at the end of the word. So this will mean that as long as it contains the word engineer, it's going to get it. All right, what am I missing now? So I already have my select. I already have my from with all the joins. I have my filters in the where. What am I missing? Yes, I'm missing my group by statement. What should I group by? So that's so here's an interesting one. Can I group by agent name? Or sorry, can I group by agent ID? Why not? Why can't I group by agent ID? So here's a question. What can I group by? This is very important, by the way. Because Patrick, because we already found the top 5. The truth is I could actually write in here a subquery that gives me the top 5 IDs. But I didn't want to make it more complicated. So this is very important. The reason I can't group by agent ID is because it's not in my select statement. I can only group by things that I already selected inside my select statement. That's very, very important. If it's not here, I cannot use it in group by. So in this case, my only options are name, number of calls, or conversion percentage. And in this case, I want to use name. So I either do a name or I can do group by one because it's the first column that is in my select statement. Either one will do exactly the same thing. All right. So when I run this, boom, I actually get my top 5 agents. I did not order them. Now that should be better. Now I should order them. In this case, I'm going to order them by 3, which is my conversion percentage. And they should be descending because I want to see my top one first. So I'm going to run it again. And here we have, which we already knew from Tuesday, we have Todd Morrow. That's our top agent with 27% conversion. Then Gloria with a 25, Agent X with 24, Dana Hardy with 19, and Jocelyn with 18. Yes, we could round. So if we write order by 1, it's going to order by their names. So if I do this, it's going to order them alphabetically. I mean, it's going to work, but they're going to be ordered alphabetically, not by conversion percentage. So it depends. And I can actually just also do order by 2, number of calls. So this is now ordered by, the first one is going to be the one that made the most calls. So we can order it any way we want, but it depends on exactly what we want. So that's the other thing. You can actually use the round function. So the round function, you have to put it in brackets. That's first of all, and it takes 2 arguments. The first one is whatever it is that we want to round, whatever number. And the second one, separated by a comma, is how many spaces, how many decimal points we want to round it into. So if I do it like that, now I just rounded everything into 2 decimal places. Let me check this one very quickly. You forgot. So Cesar, you forgot the comma after agent.name. And you're also calling agent A, so you don't have to use agent.name, just a.name, just in case. Oh, see there, that's great. Thank you. Well, that's to memorize. So that order, select from where group by having order by, that's the order that for the syntax. But the order that things actually execute is not the same. It actually goes from where select group by having order by, something like that. But it definitely does not start with select, which is that's why this becomes so important whenever we're aliasing. All right. Now remember that this exercise actually asked us to do two different things. So let me actually share this code with you very quickly so that you can play around with it. Very important. So how do I now do the same thing that we did, but for my bottom 6 agents? So these are the top 5. How do we get the bottom 6? So interesting. That's actually not going to work. So if I do ascending, I'm going to get the same ones, just in different order. So it's still Todd, Gloria, Agent X, Dana, and Jocelyn. Yes. So we need to change the where statement, this one over here. So what do we need in here? We need the agent IDs. So did anybody say them? Thank you, Sam. That's great. So yes, we need to change the IDs. That's it. See why suddenly those subqueries start looking interesting? Because we could have done just the subquery from the one that we did before, put it in here, and we get the same result without having to write it down. Okay, so when I do this, and in this case, I'm going to do actually ascending because I want to see it from the bottom to the top. That's it. So run this, and again, I get my worst agent first with a 12.5% conversion, all the way to my least worst, which is 21 with a 21.8% conversion. So Kalim, not that one, sorry, Pankaj. So assigning names. So aliases in the select statement are for the columns we get down here. So again, see as agent. So now this column is called agent. If I call this column my column, just to show you, when I run it, now this is called my column. So I can, this is just going to affect these names that appear here. But if I want to give an alias to a table, like, agent table, and any other table I'm using, like a call or agent, I do it in my from statement. And the way to do it is like this. You do call, then one space, and then the alias. And I can actually call it whatever I want. I just try to do it something very short, so things are a lot faster. So in the last code that you sent, you forgot the comma after agent. Oh, you put a.name, comma, agent. It should be a.name as agent, then comma. Yeah, the commas are always an issue. All right. Questions about this? I know it's a lot. And again, we're not going to cover a lot more. We're just going to practice a little bit of what we did. And the only other thing that we're going to do is the CTEs, which are actually not that different from subqueries, concept-wise. All right, so let's move on to the rest of the session. We already went through quite a bit, and I really mean quite a bit. So let me just redo this. We are going to talk a little bit more about subqueries and CTEs. So let me just run this 1 second. So again, we're still using the same database. We're still talking about the same people, the same agents. Everything is the same. The only thing that's going to happen is the things that we're going to be doing today. Deepak, great question. What is the best way to understand step-by-step loan codes? So one of the reasons, so both subqueries and especially today that we're going to be talking about CTEs, that is the way not just to understand, but to actually separate or SQL code in bits and pieces. So hold on, you're going to see that CTEs are going to help us a lot to understand how one thing flows into the other. Because yeah, queries can get really, really long, really, really quickly. All right, so we already have all of that. So first of all, again, let's go through just a little bit of what we did with the aliases and the were on the last exercise. And the whole concept with the aliases, again, is just so we don't have to, I'm trying to move this, there you go. So the whole concept of aliases is just so that it makes our lives easier and we don't have to write that long code. So again, instead of saying select agent dot agent ID, blah, 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 we can actually just short it down. So we can do anything. So think about it like this. This is so that in the select statement, so let's actually not start with the select, from. So the aliasing, what's happening is that we're sort of saying table A as A, all right? That's what we're doing with aliasing. So we're saying whatever table as this, but I actually don't need to do this as to select the table, just like we did before. So I could actually do select A dot, I think it's agent name, no, just name from agent A, and that's it. It's going to understand. Yeah, you can do any alphabet. You can do anything for the alias. I could call this Z. Doesn't have to be A, and just change Z here, and it's going to do the same thing. I can call it my table, and then I just call agent my table, and it's going to work the same way. So, Kalim, that's the great question. If I have multiple names, so name in several tables, like for example, in this case, I have so agent dot name, and I also want to select customer dot name. By the way, is it customer name? Yeah, customer is also name. So this is how we tell SQL these come from different tables. So I want the name and the name from agent A, and we're going to join. Well, I can't join it with customer without the call table. But yeah, let's actually do that. Join. Let's do. I need to do call. I'm not going to alias. Yeah, let's call it CL on A dot agent ID equals CL dot agent ID, and we need to join customer. I'm going to call this one C on C dot customer ID equals call dot customer ID, and that should be it. Actually, yeah, I get a lot of. I'm going to get a lot of name pairs here because it's going to give me the name of the agent and the name of the customer. But this over here, just to answer your question, this is Kalim. This is what tells SQL that these two come from different tables. So this is name from agent and this is name from customer. That's it. So yes, Manish, we can actually write a.name, but if this is coming from the agent table on or from statement, we need to alias it like this, agent A. Okay. Oh, Marie. Well, it's not just any. Yeah, we can put any letter, But I'm being the same here. I'm saying agent is going to be called A. See, this part of the code is vital. So again, that from statement, very important. So this front statement is the place where we can alias tables. So here I'm telling SQL that agent is going to be called A. That's why I can call it a name over here. If I don't do this, I'm going to get a big error. So if I don't do this, for example, I'm not calling agent A over here, I get an error. It says no such column a name because I didn't give it an alias. So we are actually the ones creating the alias for it to work. No, so for example, Sapan, order by is not mandatory, but if you put an aggregate function on the select and something else, you are going to have to put that something else or anything else that you put on the select statement in the group by, something that actually makes sense, like the name or the ID. So here's something interesting, and let's talk a little bit about something called implicit joins. So SQL is a little bit quirky in a sense that we can actually do something with SQL that's a little bit different from what we've been doing so far, and SQL is still going to understand us. So I'm going to do something particular. So I'm going to call I'm going to get the name from the agent table. I'm going to call the agent table name, A. I'm going to get the average duration from the call table, which I'm going to call B in this case. So B dot duration, B as in table B. And so again, if I'm calling the agent table A, what do I need to do here? From agent A, all right? But here's the thing that I'm not going to do. I'm not going to use a join statement. I'm going to do call B. I'm actually going to say, this is my first table, this is my second table. And I'm going to do the on statement, because I'm not doing a join, on my where statement. So A dot agent ID equals B dot agent ID. And I'm going to group, and I'm going to group by A dot name. All right. So what I'm doing here, just in case, this is called an implicit join. So instead of doing a join statement, I'm just saying, picking my tables, one after the other, just separated by a comma. Again, the rest is just aliasing like we've already talked about. Now, since I did not do a join statement, I still have to tell SQL, how am I going to put these two tables together? So the way you're putting those two tables together is going to be on a where statement, A.agentID equals B.agentID. And if I run this, as you can see, it actually works. It's going to give you the average duration for every agent. Now, the only issue here is that this becomes really complicated to use. So this implicit join becomes really complicated when we're using other kinds of filtering. So that's one of the reasons we don't generally use it, even though it's a lot shorter. This is like shorthand, but it doesn't work in every single circumstance. It works for practically all, it works for all dialects that I've used, and I've used a few. So, it might not work at some point, but from my experience, it works everywhere. All right. Now, so it becomes, I'm not saying that it doesn't work, it becomes more complicated. Let's say, and A.agent ID in, I had my ints somewhere over here, so I'm just going to copy them. So remember, these are my top 5 agents. Oops, that's too many brackets. There you go. So yeah, this still works. So the only issue is that your AND statements become your where statement becomes much more complex. And it also becomes complex when you do, let's do customer C, because then I have to do and which one was it? B dot customer ID equals C dot customer ID to group by name. Let me see if this works. Yeah, this still works. So you just have to start doing more and statements, and it starts to become even longer. Now, here's the issue. What kind of join do you think this is? So I did all these joins. Actually, we can actually select everything. Select all. I'm going to select all. I'm not going to group by because there's no need. I'm only selecting some agents. And this becomes a very big table. So what kind of join do you think this is? That's the other caveat why we don't always use implicit joins. So it's an inner join. So that's the thing. It's only going to be no, actually, no. It's so this is the complicated thing. This is doing a cross join, because as you can see, you look at how many things I got. 5,479. This is much more than a full join, because remember, we only have 9,000. No, that's fine. Yeah, no, this is an inner join. See, sorry, no, this is an inner join, not a full join or a cross join. This is an inner join, and it only works. Implicit joins only do inner joins. So if you needed to do a left join or a right join or any other kind, or a full outer join, it's not going to work. You have to be explicit on that one. So implicit joins are always inner joins. That's important. A self join? What do you mean by a self join? All right. So that's the only case where we use implicit joins is when we're doing inner joins only. Okay. Now, the important thing is that you do learn how to do joins all over the place. Those are the most important ones. And cross joins, by the way, cross joins are, let me give you an example. Select a.name. Let's do C. No. Wow, that's going to be too big. The problem with the cross join, do we have something that's shorter in the other tables just to do that example without having? Yeah, let's do that. Select a.name and select c.agent ID. I'm actually going to do distinct in this case. Distinct agent ID from agent A, and do the cross join. This is call C. Oops, on a.agent ID equals c.agent ID. And no, yeah, I can't use distinct here. So let me get rid of that one. I thought as much. So this should work. And this makes it a really, so this is just to show you what a cross join is. So a cross join, what it's going to do, it's going to mix every instance of name with every instance of agent ID that it finds. So as you can see, I'm only getting the names and the agent IDs, and it's giving me all of these combinations. So every time Michelle Williams has a call, it's mixing it together. Boom, 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 one after the other. And it makes a really big table. That's it. That's a cross join. Yeah, it's like multiple pairs. Self join. So that's so yeah, self joins. So self joins is just joining a table with itself, which you can, by the way. It does have some uses. I just can't think of anything with this particular schema, but I'll think about it. So actually, we have a 5 to 8. So let's actually take a 10-minute break, and we'll come back and do some more subqueries and some CTEs. And again, if you have more questions, feel free to ask them. And I'll try to find out a good example for a self join. Okay, let's get going again. So let's talk about subqueries a little bit more. So when are subqueries really, really interesting? So here's an interesting example. So let's say that we have an average age for customers. So let's select average age from customer. That's it. Oops, customer without a capital C. And that's it. That's our query. And that's it. We have a number. It's 24.435. Okay. That's great. So if I actually wanted to see or filter my clients by average age and see, for example, who are my clients that are over the average age, I just can go select all. Yeah, let's select everything from customer. Why does it go customer with a big where age is bigger than or equal 24.435, which is the number that we found out that is the average age for customers. So if I run this, boom, I get a list. Now let's actually make it smaller. Limit 15. So these are my top, my first 15 clients that are over 24 and a little bit under a half. And here's their ages. So 25, 30, 30, 28, etc. That works. Now, this is great if we're in a static environment. What do I mean by static? If our information never changes. But what happens if our information changes? That's where this becomes an issue. So very quickly, Kalim, select statement has to end with a comma in the first line? No. So anything in the select statement, so if I do, for example, name, customer ID, and age, then yes. All of the items, all of the columns that I want on my select statement have to be separated by a comma. But if I'm only asking for one thing, I don't need the comma. As you can see, the last item doesn't have a comma. So again, here we have the ages. So again, if I wanted to do this in a dynamic environment, which is the regular environment of when I'm working with SQL, meaning that the client tables are changing. There's going to be more clients added. And if I add more clients, my average is going to change. So yeah, if I hard code it like this, then if I run this tomorrow and there's more clients in my list, this is not going to work anymore. So this is why subqueries become very powerful. So instead of actually having this query, we actually go back to the previous query, the select average age from customer, and we put it as a subquery in here. So select average age from customer. And that's it. Oops, I forgot the bracket. So in this case, I'm doing exactly the same thing we just did, but without hard coding it. So I run this and I'm going to get the same information, the same clients, all great. But the advantage now is that if tomorrow I come back and I want to do the same thing and the customer list changed, I still get the average age. I don't have to actually go look for it again. So if I'm coding this, because I'm going to be running it over and over again, this is the way to do it. And this is the power of subqueries. So very important. Any more questions about subqueries? For now, I mean, I'm sure there's plenty, but in general, for now, and I know you want to practice a lot more of this, but the important thing is that we can use it to get a particular number or a particular piece of information. Like for example, if I wanted to get the names of everybody, but instead of the average age, I wanted their ID numbers or only a particular set of ID numbers like we did before, like we did, for example, for agents, I could actually, in the subquery, build a whole query that helps me find those 5 agents and just get their IDs from there. Sapan, I'm not sure if I understand your question for which type of join we use in. So in is not, has nothing to do with joins. So in, so for example, let's say we're age in 80, well, let's say 20, 25, and 30. So if I wanted to know which are my clients that are age 20, 25, or 30 exactly, I can use an in statement in my where. All right, this. So going back to the previous one to answer the other question, boom. So average age, if I run this by itself, so what I wanted to see is what it does. So it's going to give me the average age. So it's going to go into the age column of customers. As you can see, there's an age column that has all of the ages of the clients. So think about like this column, and it's going to give me the average. That's it. That's all it's doing. No, you don't need to run it. I don't need to actually run this for it to become a subquery. Just like this. So this SQL is going to do it by itself. It's going to run this one first, get that number out of it. So get this number, and then it's going to run the rest. So, but SQL is going to do it all by itself. No, we can use we can use subqueries in the where statements. We can also use them in the select statement. Yes, we can use a subquery anywhere in the where statement. So we can use an in, we can use a bigger than. I mean, I could do I want them age less than the average age. I can actually put it almost anywhere in my where statement. All right. So let's actually do an exercise. And this time you do it, and then we'll go through it together. So what I want you to do is to do a subquery to get the name, the call ID, and the duration for every call where the duration is greater than the average call duration. Okay? So again, the name, the call ID of the agents, of course, and the duration for every call that was longer than the average call duration. And make sure to exclude calls that have a duration of 0. And just to make it a lot smaller, use limit 15. All right, I'll give you 5 minutes for this one. Or your code. And the recording is back on. One more minute. All right. So let's actually do this one two different ways, just in case. So the first one, I'm going to do it with a regular join statement. And the second one, I'm actually going to do it with a implicit join, just for practice sake. So I'm going to select a.name, which is the name of the agent. I'm going to call the agent tabled A, but I'm going to do that in my from statement. Then I'm going to do what's the other thing that we needed? The call ID B. I'm going to call it C. I like it C better. C dot call ID. Yep, that's the one. And call ID and duration. So D duration. Great. Then I'm going to go from, and I'm going to start with agent A. By the way, here you can do either as A or you can just do A. The as is optional. Join, and I'm going to join call C, and we're going to join it on A dot agent ID equals C dot agent ID. And here comes the fun part. So the fun part is the where statement. So we need to do a where the C dot duration, actually C dot, it's average, sorry, it's the duration is the average of the duration. So C dot duration is bigger than or equal to, and because we want the average, we need to do a subquery right here. So we're going to select average, it's C dot duration. Actually, I don't need the C in this case because this is its own subquery. So average duration from, do I actually need it or don't? I'm actually going to use it just to make sure there's no problem. C dot duration from, this is call. No, actually, I don't need it. I'm going to get rid of it because I would have to actually alias it again in here. From call, and very important. This, I'm going to have to do a where statement in here because it wants me to exclude all calls that are 0. So where duration is bigger than 0. So that would be my subquery. So just to check, it's always great to actually run that subquery. And there you go. That actually gives me an average, which I'm hoping is the right average, removing all calls that are 0 in this case. So that's it. With duration, we're going to order by. Yeah, let's order by. Why not? So order by, in this case, C dot duration. And we wanted descending. So the longer calls at the very beginning. Sending, and let's limit 15 because they want us to limit it by 15. So that would be it. And I run this and I actually get all of the calls that are longer than the average. Well, just the first 15. We can use and where, by the way. Pankaj, you're asking if we can also use and instead of where. Where would you use the and? Oh, well, it depends because I actually not in this case. So we're using the where inside the subquery because I want to remove all of the calls that are 0 from the average. So if I do it somewhere else, it's not going to take him out of the average. My average is going to be a little bit. So if I remove this from here, I actually get a different average. Let's actually run this and check it out. See, I get about 125. But if I do here where duration is bigger than 0, and when I run it like this, oops, I need to run the subquery was 125 and something, and now it's 179. Yes, so this where is for the subquery, not for the main query. And that becomes really important. How do I know it's asking for the agent name and not the customer name? Oh, here we don't. Actually, that's a really good question, but I actually said agent just in case. But yeah, you could have done for customer and that would be fine. Now, if I wanted to do this instead of with a regular join, if I wanted to do it with an implicit join, I could actually do it like this. So agent A, comma, call C, but I have to add something else here. So this would have to become an and here I would have to do where A dot agent ID equals C dot agent ID. So again, similar code, same result, but one is with an implicit join and the other one is with a regular join. So let's check it out. Let's see if I can see this 1 second. Oh. By the way, when you're sharing your code that doesn't work, it's always good to also share the error that comes out of the end so that we can actually see what the error might have been. Hassan. Oh, that was strange. You didn't close your subquery and you're using an and statement that it shouldn't be an and. So let's actually go back to the other query. Just in case, Hassan, your subquery has to look like this. There has to be a where, not an. You put an and here instead of a where, and you didn't close the bracket. That's it, and that happens. It's never mandatory to use aliases. No. So here's. All right. Let me actually show you what happens when we do that. I'm going to select all from. Oh no, actually, I'm going to select. This is what happens. Select name. This is going to be interesting. From agent, join a call on agent dot agent ID equals call dot agent ID, and I'm going to join customer on customer dot customer ID equals call dot customer ID. All right. So let's see what happens when I do this. See, I'm getting an interesting error here. It's right here. It says result ambiguous column name. Why do you think that's happening? So yeah, Marta, that's actually it. It's not a problem with the names. When it says ambiguous, it's saying, I have an issue. So this is an issue that SQL is having. It's getting really confused. It's saying, well, you're telling me that you want a name, but do you want this name or do you want this name? See, that is the issue of what happens when we don't, the alias is not necessarily what we need, but I actually have to tell it. Whenever I'm doing this, I have to say either agent.name, so that's an option, or I have to do customer.name. Whether I do an alias or not is optional, but I have to tell it where I want from which table do I want that column. And that becomes important because we have some columns that are the same, like agent ID, and call agent ID, or customer name and agent name, which are not the same. Well, the thing is that if I do, for example, c.name, and I don't alias it here after customer, then I'm going to get an error. See, now it says no such column name c.name. I actually have to alias it here for it to understand what I'm talking about. And yeah, after I alias it, I actually have to use it. That becomes really important. See, then it works. So if I alias it, I actually have to use that alias everywhere else. So yeah, you have to specify where you want. So here's one of the rules of relational databases. Tables cannot have the same name. You cannot have two tables with the same name. But, and inside one table, so again, tables, each of these tables, agent, call, customer, they cannot have the same name. Doesn't matter how many tables you have. They all have to have unique names. And then within a table, no two columns can have the same name. But in different tables, columns can have the same name. Like, you know, redundantly, this name over here. So if you want this name and not this name, you have to let SQL know. That's what, because if not, SQL is going to say, this is ambiguous. I'm not understanding. So yeah, it's one of those things that you definitely need to do. All right. Let's move on to our last subject of the day, which are CTEs. So CTEs is, CTEs means that you're sort of creating a table before you query it. All right. So this is a way, so here is an example of how we use subqueries, in our select statements. So we can, in our from statements, which we can. So see, here is using subqueries inside from. So I'm selecting everything from this table, select all from customer, and I'm doing a full join on call where name is null. So I want the things that are null. Remember that we had some null columns. And I'm joining that whole thing with this other table, which I'm actually just declaring it in here. So let's actually take a look at them. So we have this table, which was all the null values in our customer table. And then we have this table, which is all of our null values in our agent table. So agent and call. And I'm just joining those two together. All right, I'm doing a full join on them. So again, one is 15 rows, the other one's 16, one row. So I get 16 rows in total. So this is one way to do it, but this becomes really complicated and it's really hard to read because you're putting too many, there's a lot of select statements or a lot of subqueries inside the queries, especially in the from statement. So the other way that we can do it is using CTEs. So CTEs just change the way we work a little bit. So we start our query, that's with, that's the start, just with, and then we give the table a name with my table, let's say, my table as, just like we do aliasing. And then we do our query or whole subquery inside these brackets. So here we do, select all from, I'm going to say select all from agent. Okay. So literally, now, of course, this example or this table, this is just this table. This is it. Or even better, let's say a select all from agent where agent ID is bigger than 5. Okay. So now this becomes a new table. By the way, what is the name of this table that I just created with a with statement? Yes, it's called my table. It's right here. So once I create it, so after this, I can actually use it. So I can select all from my table. And this is just a table. So it shows me, it's going to show me exactly the same thing, but it's all my table. Or I can do, for example, select a name from my table, and I just get the names. But this table suddenly becomes a new table. And of course, this is a lot easier because it's not in the middle of my original select table. So I just did one thing. So now imagine the same thing that we did before. Okay. Or let's actually go for another example, and we'll end up with that one, which is a little bit more complicated. So let's say we start with, like we did before, average age from customer. And we run this and we get this number. So we have it right here. All right. And we already used it, like before, as a subquery. Oops, that's not it. And let's copy it this way. And we can use it as a subquery. So select name, customer ID, age from customer, where age is bigger than the average. So that's the same thing that we did before. I'm using it as a subquery. But if I want my queries to be a lot cleaner and a lot easier to use, so yeah, the CTEs, that's called common table expressions. So it's just like a table that I created from my database. They always have to be on top. So I'm going to do with, and in this case, average. Just call it average. Oops, I forgot the S. And I'm in here. I'm just going to select average age from customer. And that's it. This now becomes my new table. And this, although this table is just a number, because if I run this, look, it's just a number. But now my select statement becomes a lot cleaner. So select name, customer ID, age from customer. Oops, just customer. Where age is bigger than or equal to average. So now I don't have to do the whole subquery in here. Oops. No such column average. I miss maybe like this. Give me just a second. Average. No, we're going to get an error, of course. No, not missing the alias on my CT. I'm missing something else, which is very important. Because again, we need to reference it properly. It turns out that I didn't. I actually have to reference as average age because I actually didn't call that table anything as average age from customer. Oh, nope. Sorry. This I have to actually do select average age. And actually this I actually need to alias it here, average age as average age from average. So now I can use my subquery in here. But this is a much simpler subquery, and I'm getting the information from here. So that's the thing. Now, yeah, thank you. The CTE, no, the CTE is in brackets. So the issue here is that this is a lot easier to read. And of course, this is something simple. Generally, I would just use the subquery in here without having to do so much going through and for. But you can actually start seeing that if you build one table, then you build another table, then you build another table, then you run your queries, things become a lot easier. So again, the whole issue is I can actually build the select. Let's actually go to another example. It's gonna make a lot more sense. So remember that we did this before, right? Where did it go? Here. So this is a very messy query over here. This is the query for putting together. Oops, I copied it badly. Boom, boom. Better? There you go. So this is the query to putting together the both tables where we have null values connecting or calls and customers, and the null values on calls and agents. Now, this is a little bit complicated. So this is a lot to look at. So the way we can fix this and make it a lot simpler is to actually create CTEs. All right. So what we're going to do is we're going to create a CTE. So by the way, with double dashes is the way that you do comments on SQL. So this, I do double dash and I can put anything I want here. It's just comments, and SQL is not going to read it. So let's actually create two CTEs in this case that were the original ones that gave us this table, so that our query is going to look a lot easier to read whenever we come back to it. So I'm going to call this one customer outer call. So this is, yeah, that's fine. As, and I open brackets, and inside the brackets, I do my first query. So I'm going to select all from customer. I'm going to full join call on. I'm going to copy this. It's going to make my life a lot faster. Yeah. So I'm selecting everything from customer. I'm joining it with the call table, and I'm just picking everything that is null. So this is my first call. And again, if I run this, this is what I get. I get 15 rows. All right. So now I saw it up there. Great. I just did one table. It turns out I can do more. All I need to do is separate them by a comma. So in the second, look, you don't have to do with again. You just have to do it once. So now I'm going to do the second one. I'm going to call it agent outer call as, and again, open brackets. And in here, I'm actually going to, again, make my life easier. I'm just going to copy this over here. So I'm selecting all of the null values in the combination agent and call, which is one row. This is my agent -1, which doesn't exist. So it turns out that now that I did that, as long as I remember the name of my tables, I can forget about all this code. It's already done. I know it's working, and I don't have to worry about it anymore. So let's say now that I wanted to join those two tables. Now it's going to look a lot nicer and a lot simpler, because all I have to do is select all from my first table that I created, which is customer outer call. And I can do a full join with the agent outer call. And I'm actually going to call this one C. I'm going to call this one A just to make my life easier, because I still need to do my on C.name equals A.name. So I'm going to join them on name, because that's where they join. And now, when I run this, I get the same result. Now, as you can see, the big difference is that this is the original code that we had. This code is much harder to read than this one. This one's much neater because I have one block of code followed by another block of code followed by my final select statement. And that just makes life a lot easier. So if things don't have, so sometimes if things don't have a common column, we can't join them. That's something very important. So to join two tables together, they need to have something in common. All right. So let's actually do one more example, and I'll give you one more exercise. We still have enough time. So let's actually take, let's copy this, make my life faster. So I'm going to create one CTE in this case. It's going to be called Total Agent Customer Interaction. And what it has, so I'm going to run it first, what's inside. And what I'm getting is the agent ID, the customer ID, and the sum duration of calls that were picked up. And they're grouped by agent ID and customer ID in this case. Okay. So just the agent ID, the customer ID, and the sum of the duration. So all calls between agent 0 and customer 1 lasted 536 minutes. Calls between agent 0 and customer 10 lasted 264 minutes. So that's my table. Now I'm going to take this table and I'm going to do another select statement just to make my life easier. So again, I'm going to copy it. So I'm going to select the agent ID from this table, the customer ID from this table, and the sum of the duration from this table, and the customer age, which I don't have in this particular table. So I'm going to get it from Total Agent Customer Interaction, which is this table that we created over here. And we're going to join it with customer, which is our regular customer table, where customer ID equals customer ID, and we're going to order by agent ID. So once I do this, now I'm going to get something more interesting. Now I actually get the age from everyone. But look at it. I'm getting how much, so I can do other things with this one. So I'm getting the interaction between each agent and each customer, meaning how many minutes they've spent on the phone, whether it was one call, two calls, etc., and their age. And if you think about this, I can actually keep working on these tables to get some very interesting information. Like, for example, how many minutes does it take on average to make a sale? How many calls does it take to make a sale? And I can do this by combining all these tables. So just in case, we'll do one more exercise. So this is what we want to get on this one. Yes, we can give CTEs aliases here. So within a select statement, you can give anything aliases. So this total customer interaction could be called T, but I would have to go back and call it the same all over the place. I'll actually do it on this example. So let's do a CTE. And we want to get the name, the call ID, and the duration for every call where the duration is greater than the average call duration. All right. And make sure you exclude calls with the duration of 0. So remember the exercise we already did. Now do the same exercise, but using a CTE instead of a subquery, just for good practice. All right. And yeah, we have 5 minutes. And then you'll have 5 more minutes for questions. We've had a lot of time for questions today, which is good. By the way, Sapan, if you have tables that are the same size, you can actually union them together. So union is just getting one table and putting it on top of the other. But if they're not the same size, the only way to join them is they have to have something in common. I mean, you can still do a full outer, yeah, you can do a full join, but you're going to get, separation. And by the way, you can do as many CTEs as you want, and you can actually combine you can do one CTE here, then another one, then join those two together on a third one and use that one, and so on and so on. My record at the time, I think it's like 20 something CTEs before running the final query. It was a lot of data. So and it was really hard to just try to get it smaller and smaller and more comprehensible. Let me check. Pankaj, you're missing your query. You did two CTEs and then just stopped, and SQL doesn't really understand that. So if you do a CTE after you finish, or as many as you want, after that you have to do a query. The final select statement. All right, I'm going to do this one the fun way and try to combine absolutely everything we've seen today, which is a lot. But, query, subquery, CTEs, everything. So let's actually get started. So in this case, I'm going to create my CTE. So again, let's start with a with statement with, let's call this one, what do I call this one? That's always a good question. It's going to be temporary table, so I'm just going to call it, no, see temp. I hate using temp because then I'm going to call it T table, which is for temporary table, as, open up my brackets. All right, so I want to select a.name. I want yeah, I'm going to call this one B call ID. That's going to be my call table. And I want B dot duration. That's going to be also my call table. And yes, and let's do now we need to do all over aliasing from agent A, just to make sure that people understand that agent A. And we're going to join that one. Oops, join it to our, what is it? Oh, our call table, of course. Call B on A dot agent ID equals B dot agent ID. And here's what I'm going to do my filtering. So we're just going to filter by duration. So B dot duration is bigger than, and I'm going to do a subquery in here. Just so you can do subqueries on your CTs. You can do subqueries anywhere. So select average B dot duration, duration from call B. I'm just making sure that I call call table B everywhere, and I want to make sure where B dot duration is bigger than 0, and that's my subquery, and that's it for my CTE. So just in case, always a good idea. I'm actually going to do this over here just so I can see the whole thing. And always a good idea to run your subqueries and near from, I forgot a bracket. See, too many brackets. So let's run this again. And yes, I get my average duration. So that's working. Great. And just to make sure, is this working? Yes, this is working. So I'm already getting all the names with the call ID and the duration of the calls that were bigger than the average. Great. So now what do? I'm going to select everything. Select all from T table. I'm going to call it T. Actually, I don't need to call it T because I'm not going to do anything else with it. I'm not joining it, so that's fine. So select everything from T table, and no, actually, yeah, I'm going to call it T because now it's going to get more interesting. And I'm going to order by. So I get it. I get them in order. Order by T dot duration. Yes, T dot duration. And I want them in descending order. And of course, I'm going to limit 15. Limit 15. So in this case, I did this whole thing, and with this select statement, I can just order them in a very comfortable way so I can see which are the longer calls. And when I do this, as you can see, I get the longer calls at the beginning. And these are the top 15 calls, or the top 15 longest calls that we have had in the whole in our company, in our call table, that are bigger than the average, by the way. That's also very important. So why did I use the same alias B for both call ID and duration? So no, B is the alias for the call table. So imagine when you see that I'm doing B agent or B duration, is the same thing as doing call.agent ID and call.duration. All I'm doing is replacing the name of the table with the alias. Just makes my life a lot easier. That's it. Wow, that's a big question and an interesting question for the end of today's session. What are the best practices while writing queries? So I'm sure there's tons of them. Well, first of all, the most important thing when you're writing queries is that you understand what you're trying to get to. But once you start writing them, make sure that you write them as clearly as possible, meaning that they're readable. So this whole thing that I do, that I like them very ordered, that when I'm doing my join, I do it like this, that when this select statement, I want to look at the whole thing with the brackets. So these are just good practices when writing code so that it's readable, so that when I go back, I can actually figure out what I was trying to do. Also, this is not good practice. Something like a temporary table or t-table, try to call it something that's important, that is reflective of what you're trying to do. And the other important thing is use comments. So again, double dash, here you can write comments. So here's one of the most important things that happens, is that you write code, then you come back to the code a few weeks later and you forget what you were doing. And if you didn't write comments, you're completely lost. You're like, what was I doing? So there's a saying that the worst code that you will ever see in your life is the code that you wrote 6 months ago. And it's true. Trust me, it happens to me all the time. And as time goes by, you learn to write more and better comments so that your code is more readable. So it's a lot easier to see code in one column that is not very long, and that everything is organized in a way that it's easy to see if you make a mistake, if something happens, etc. And your queries, just do one. Yes, indentation is very important, and it's going to become more important once we start learning Python. And my first language was Python, so I'm very indentation oriented. All right, any more questions? I think we're actually out of time, and I don't know if there's any announcements.